Hi everyone, welcome to our webinar today. We're excited to get started, but before we do so, we have a couple of announcements we'd like to make. Today's webinar is titled Real-Time Analytics Using Data from IoT Devices. Today's webinar is being recorded and we'll be able to send a follow-up email to the email address that you registered for this webinar with by end of day, Monday of next week. If you're interested in seeing the recording or the slide content before that, feel free to follow us on YouTube as well as on SlideShare. We have a channel on both that you can see the content usually within 48 hours of the webinar. So feel free to search there for the title of today's webinar. Additionally, throughout the presentation, you will be able to submit questions for our presenter and moderators at any time in the Q&A panel. So please feel free to submit any questions you have. We'd love to engage with you and answer those questions. Again, today's webinar is titled Real-Time Analytics Using Data from IoT Devices. Our presenter today is Ryan Nienhuis. Ryan, without further ado, I'll turn it over to you.
Hello, my name is Ryan Nienhuis, and I'm a Senior Product Manager on the Amazon Kinesis team. Today, we're going to be covering real-time analytics using data from IoT devices. We're going to discuss how to get data into the AWS cloud from IoT devices, how to process that data in real time, and we're going to go through some real-world scenarios. You'll learn about a lot of different AWS services as well as best practices associated with this use case. So some of our learning objectives today, I already mentioned a couple of them. The other thing I would highlight is that there's a number of different ways to solve this problem. And we're going to go through a couple different scenarios. I'm going to offer you a couple different options and best practices associated with those options. Before we begin, I'd like to bring attention that AWS is running an IoT app challenge. And the challenge is to build an app that very similarly follows what we're going to cover today in the webinar, that collects and processes sensor data or some other IoT device data to solve a particular user need. The reward is $10,000, as well as we have some other prize pools, so Amazon Echo, AWS credits, and you'll have an opportunity to meet with AWS product team leaders if you have a winning submission. We have a lot of resources, including a Slack channel, email addresses to help out, a set of forums. There are links and additional information at the link at the top of the page. Great. So what is the end goal of what we're trying to accomplish today? I'm going to focus on how do you ingest data from IoT devices using AWS services? How do you process that data from those devices to get useful information and then visualize it? So on the left-hand side, I have a dashboard that I've taken from one of my favorite open source sort of real-time dashboarding solutions called chart.js. And you can see it measures like health data and gives you useful information that's continuously updated. And on the right-hand side, we've got another open source, very popular real-time visualization that's Kibana, which is often used with Elasticsearch. It's very, very popular for operational-like use cases, but it can be used for virtually anything. I highlight this is because we're going to be going from a very hard problem to solve in getting device data into the cloud and analyzing it in real time to visualization. And I'm going to show you how you can use a set of AWS services to solve that problem in a couple different ways. So I've mentioned a couple times that why is solving this problem so hard? First and foremost, the designing for failure for a global real-time distributed system is in its very nature very hard. So IoT devices are purchased, installed, maintained in a very global setting, not just regional. So you've got things like latency to deal with, things like how do I get visibility in two different countries or regional areas. Real time is important here. A lot of these devices, to get visibility about what's going on, you need to be able to process things very quickly. And this is from end to end. So not only just getting that data into the cloud very quickly, but also just processing it very quickly. And then just distributed systems are hard. By its nature, because IoT systems are global, because the throughput that we're talking about processing is very high, we are primarily dealing with distributed systems. And they're a lot harder than running one single monolithic apps in certain situations. The throughput comment leads us to the next part of the problem. The infrastructure required to process from lots and lots of different devices, billions of devices, sending trillions of messages is expensive. So you can do things like, okay, maybe I won't send data as frequently, but then you get less visibility. So how do I do this in real time to get that visibility from my devices quickly, cheaply, and efficiently? And then the last thing that I'll bring up is the management overhead and scale limitations impede innovation. And what I'm trying to say with this point is that not only is building the system hard, getting the infrastructure set up, but operating that system is also difficult. So what AWS services can help you out here? So we offer a lot of different services. I'm going to focus on a couple of them, specifically two sort of areas that really help solve this problem very, very well. And that's how do I efficiently and quickly get data from my IoT devices into the cloud, analyze it, get useful information, and then produce dashboards. So the first set of services that I'm going to talk about are AWS IoT services, and they make IoT easy. There are two primary ones I want to draw to your attention. AWS Greengrass. AWS Greengrass provides local compute, messaging, data caching, and sync capabilities for connected devices. They're really focused on, there's a portion of the IoT space that you have to be very low latency. And this is where AWS Greengrass really provides a set of services and capabilities that serve this niche. You can run IoT applications seamlessly across both the AWS cloud and local devices. And it integrates very well with AWS Lambda, our serverless computing offering. The service I'm going to be spending more time on today is the AWS IoT platform. And the AWS IoT platform provides a set of capabilities that make it easy to interact with data from, interact with devices from the cloud, make changes to the cloud, have messaging between devices and the cloud, as well as intake data into the cloud. So our first learning objective was, how do I easily get data into the cloud? AWS IoT platform is going to help us do that. The next set of services we're going to be talking about is Amazon Kinesis. And Amazon Kinesis is focused on streaming data. Streaming data is any sort of data that is continuously generated, captured, processed, analyzed, and delivered. And the key aspect of that is continuous. So log data, mobile devices, web applications, web clients are all great use cases, but an even better one is IoT. In IoT, you have these devices that are continuously generating information that needs to be captured. Amazon Kinesis Streams and Firehose both provide a mechanism for that, and we'll go into a little bit deeper on those two services and how they can help you out. Needs to be processed and analyzed. Kinesis Analytics provides a great mechanism for doing that by allowing you to apply SQL data continuously on the data as it arrives. But when you think of Amazon Kinesis, what you want to think of continuous and streaming, so the data is in motion as it moves from IoT devices to the cloud. So firstly, how do I get data from my devices to the cloud? So this is the AWS IoT platform or framework and the set of capabilities that AWS IoT offers. They offer a device registry, a gateway for interacting with the devices, a message broker, which allows you to set up device shadows, as well as a rules engine. The rules engine allows you to send messages and set up configuration or various things to forward data onto specific services. And you can see on the upper right-hand corner there, analytics and Kinesis are highlighted quite a bit, but there's a lot of different offerings here. The path we're going to focus on today is getting data from your device through the device gateway to the message broker and then forwarded to a Kinesis services using the rules engine. So the message broker provides low latency, reliable message routing between your device and the cloud. It offers a pub-sub model, so you can basically decouple your devices from your applications. And it offers some very, very useful data transformation routing using a fairly feature-rich rules engine. We're going to go through in a little bit detail what a rule looks like, but just know that this part of the IoT platform allows you to get data in and route it to where it needs to go. And for our dashboard use case, This is the first step. So the rules engine, again, allows you to route data to specific AWS services. And they range from Amazon Kinesis to CloudWatch to SQS. There's a lot of different things you can do here. We're going to be focusing on analyzing streaming data with Amazon Kinesis, as well as getting the data to an Amazon Elasticsearch service. But the point of this slide and what I'm trying to convey here is that the power of the flexibility of the rules engine allow you to send the data wherever you need it to go. So what does a real world scenario look like? I threw up a bunch of different concepts to you guys. Imagine you've got a set of temperature sensors, so rain, wind, temperature, weather sensors, rain, wind, temperature, and vibrations. And you have a hub that's sort of like a weather station that's connecting through MQTT protocol to the AWS IoT platform. This is where the message broker really comes into play. You can set up a rule that will either filter or transform records as they come in, and then an action to forward the data to an Amazon Kinesis stream or an Amazon Kinesis Firehose delivery stream, which are two mechanisms for continuously capturing high volume IoT data at scale. What does a rule look like? So you have an MQTT topic that you write to and interact with the AWS IoT platform to. So here's an example structure of a topic where for the weather station, so you have a weather and then geolocation, station ID, sensor type, sensor ID. So topics allow you can have multiple topics and allow you to get fairly granular with how you ingest data. You can also simplify it and do it by region, or there's various other strategies, but the point here is that you can be as granular, as coarse as you need to be as you receive data into the cloud. When you set up a rule, you can use a SQL statement to help filter or transform data as it arrives into the cloud. This is quite powerful because a lot of data coming into the cloud, coming into the AWS IoT platform is going to be raw sensor data and will need to be cleaned up. And over the course of sort of this pipeline of getting the data to analytics services, you'll see we have various steps of cleaning up. So here we're selecting from various topics, providing some labeling to them, sensor ID, station ID, so on and so forth. Casting values to get the transforms to start to apply some structure to the data so we can do further analytics. You notice that I'm pointing to a specific topic in this slide. This references the MQTT topic segment that I brought up. And in this sort of like hierarchical fashion, you see topic 6, topic 4. You can select specific things from the topic to provide context to your data as it arrives. So if my incoming data only has a set of like values or detailed information associated with it, you can use IoT rules to basically provide context to that information. This is my sensor ID, this is my station ID, so on and so forth. So the transform payload is a lot easier to process and analyze, which is getting to our end goal. So now I've got data sent to the cloud. How do I analyze the data in real time? So I'm going to introduce sort of a simple pattern for streaming IoT data. And this is generally follows what streaming data pattern that follows more broadly, not just for IoT, in that you have a data producer, an ingest layer, and a data consumer. And all of these are acting continuously. So the producer is continuously creating, writing data to the stream. When I say continuously, this is not an IoT device that wakes up every 1 week and sends a large, massive file to the cloud. That is not sort of a streaming pattern. A streaming pattern is, you might wake up every minute, you might be writing every second, you might be writing every sub-second from your devices to the cloud through the IoT platform. The ingest layer is a combination of AWS IoT and Amazon Kinesis. The value that Amazon Kinesis provides here, specifically Amazon Kinesis Streams or Firehose, is it allows you to durably store the data in a temporary buffer, and it supports very high throughput in a very inexpensive manner. So both Kinesis Streams and Firehose deal with very high volume writes at scale very, very efficiently. And then a consumer. Again, the consumer is continuously processing data off of the stream. It's going to continue to work on that previous data sample that I had to clean it, prepare, and aggregate it. And this is where your real-time analytics will start. So one option for performing real-time analytics on IoT data is Amazon Kinesis Analytics. Amazon Kinesis Analytics is a data consumer. So if your IoT device is a data producer, Kinesis Streams and Kinesis Firehose provide capabilities to serve as that temporary buffer or temporary storage solution for getting data into the cloud in a very cheap manner. Analytics provides that mechanism to read the data from Streams and Firehose and produce real-time analytics. You use SQL to compute those analytics, and one of the value propositions that Kinesis Analytics provides is it auto scales. So you just write your SQL query, and we scale your application based off of the incoming throughput and your query complexity. So what do we mean by SQL on streaming data? So the reason why SQL is such a great thing is that it's very direct. So part of the reason why the IoT rule engine uses it, part of the reason why we use it, is that you can tell us expressly what you want. You'd like to count the number of sensors over the last minute, and possibly filter by any sensors with a specific prefix. That type of computation for analytics workloads is very easy to express in SQL. At a very high level, one of the most important concepts of writing SQL over continuous data or streaming data is windows. Windows, they're typically called either tumbling windows, sliding windows, or session windows, but windows provide a bound to your data set. So when you write a SQL on, say, a traditional MySQL database or some other database, when you execute that query, it looks like that data at a point in time. And that's what bounds the query and allows you to provide a result. But if data is being continuously captured, it means that data is unbounded. So we need some way for you to tell the system in SQL when to produce results. And windows are the mechanism typically to do so. So for example, a tumbling window produces a result after a fixed time. So in this example that I have in the below, you can imagine you're doing counts over the first window, and you're doing so every 3 seconds. So we add up all of the records in that window, we produce a result, and then we move on to the next window. So windows can be fixed size. So tumbling is an example of a fixed size window where the size in this particular case is t is equal to 3. They can also be variable size like session windows where you don't have a predefined knowledge about how long a window is going to be. The other thing is that they can be overlapping or not overlapping. So as an example, in this, I show you window 1, window 2, window 3. These are not overlapping windows. Tumbling windows are not overlapping. In contrast, a sliding window is continuously overlapping. A sliding window produces a result instead of at the end of a time period, at the end of any time we see new data. So if it does a running count, a sliding window will produce in window 1, 1, 2, 3, 4, 5, and then as rows fall out of the window or add to the window, it gets incremented. So it'll go down or up based off of that. Tumbling windows are great for real-time analytics. Sliding windows are great for like operational use cases where you're trying to react to the data in real time. Another great service for real-time analytics is the Amazon Elasticsearch service. And Kinesis Firehose provides a great integration with the service specifically for IoT use cases. So you can use a Firehose delivery stream to deliver data to Elasticsearch very, very efficiently and cheaply. So why wouldn't you just write to Elasticsearch directly? What Firehose does is it provides that temporary buffer. And as I mentioned before, that's an important step in delivering data to downstream systems. So if your data is coming in at 1,000, 10,000, 100,000, 1 million, or even more events per second, it means that you have a very, very high volume stream. And writing those data rows one by one to individual data stores is not very efficient and puts a lot of load on those systems, so they can do less analytics. So what Firehose does is it takes that high granularity data, so that every record receiving a certain number of seconds, so 10,000 records per second, and it groups them into much larger files so that you can efficiently buffer and then load into Elasticsearch. Elasticsearch provides a set of analytics capabilities some of the most powerful real-time search capabilities, so full text search, so things like doing grep and other items like that at scale, as well as the ability to set up custom dashboards and reports. A little bit more about Firehose data transformation. What's great is that I mentioned that we're going to continue to apply more and more structure as data comes in from the IoT devices to the cloud. Kinesis Firehose provides that. It allows you to do invoke Lambda functions, which is our serverless computing service, to take an array of records and separate them out, to apply additional structure on them, to do a data enrichment, and then save it to the configured destination, in this case, Elasticsearch. This means that when the data arrives on Elasticsearch, you can very, very easily start doing your analytics. You've applied a nice structure to them, the data's been cleaned up, any, say, malformed data has been filtered away. So what type of aggregations can you do using the Amazon Elasticsearch service? So there's two important concepts here. Buckets, which is sort of a collection of documents or records meeting some criteria, and metrics, the calculations on those contents. So in this example I have here, I'm bucketing by time, and this time might be minutes or whatnot, and the metrics might be just counts. So similar to the windowing concept, this bounds the data set. So as data arrives, we assign a collection of documents to a bucket with a new time frame, and your data evolves over time. This is how you get real-time analytics from Amazon Elasticsearch. So a little bit in more detail of the types of things you can do is and the correlation. So you might have a specific host and a specific field like an HTTP post. Perhaps for this might be a specific temperature reading or something like that, but a field, which then gets bucketed and then counts. So it gets aggregated based off of how you want your custom report or custom dashboard set up. You can also do very advanced analytics with Amazon Elasticsearch service. So here I have a visualization of S3 buckets where they have the ARN setup, the region, the event name, and then the count. You can do the same thing with the IoT data. So imagine you could have, the region, the state, the city, the device, and then the count. Or you can organize at a coarser granularity as well. So what I'm conveying, and that's very similar to the example we described in the AWS IoT rule. But the point is here, you can get fairly advanced in the analytics, and it's still in real time. So what are some best practices for analytics solutions on IoT data? I've presented a bunch of services that we have. How do I stitch them all together to a solution? So I'm going to pick a use case. I'm going to pick continuous metrics. So say you want to compute metrics from sensor logs, like temperature readings or something like that, or build leaderboards for device types or key stats. So I would give me the top 10 active devices over the last minute and continuously do that. When we say continuous, this is what we sort of mean. Always be reproducing and refreshing the result. This is different than, say, historical analysis, where you're saying, over the last day or week, give me the device with the most activity. We're saying, right now, give me the visibility into what device has the most activity or the highest temperature reading, so you either can react to the data in real time or make decisions based off of your business in real time. There are some key requirements when you do this sort of real-time computations. Handling late and out-of-order data is extremely important. You need to have a mechanism to deal with that. So what I mean by late or out-of-order data is a device might fall asleep or might lose connection or something like that for a period of time and then wake up and send data. And that might be a minute later, it might be an hour later. You need to be able to handle that. You need to be able to combine results with historical data. Real-time data is for only a select set of use cases is valuable immediately now without the context of the historical data. So you might be computing a temperature average right now, but without the context of what the temperature was over the last week, you may not know whether it's high or low. And then the final requirement is let's quickly provide the data to both tech, like systems engineers or operational engineers, as well as non-tech users. So like business stakeholders, product managers, and whatnot. So here's an example that uses Amazon Kinesis Analytics and the AWS IoT platform to compute average temperatures every 10 seconds. So imagine you have a set of IoT sensors. They're going through the AWS IoT platform. The AWS IoT platform is applying a rule that sends the data and an action to send the data to a Kinesis stream. And it's perhaps is cleaning up data, adding that context that we showed in the beginning of the presentation. The next thing is Amazon Kinesis Analytics is doing, say, a tumbling window. So that windowing concept, every 10 seconds computing average temperature across all devices, and maybe much more. Maybe it's also counting the number of unique devices that are online, the number of devices that have been disconnected in the last minute, those types of computations. It is then sending that data to a MySQL database through another Kinesis stream and Lambda function, which provide, again, a buffer and allow you to do a final post-processing step to prep the data before you load the data in the database. So what are some best practices with this real-world scenario? So I mentioned handling late and out-of-order data. There's two typical strategies for that. One is if you have a very, very real-time use case, meaning it's for operational purposes or something like that, some customers will decide to just drop the data or filter out all late data and send it to, say, an S3 bucket or somewhere else for long-term archival. The other strategy is to have your windows deal with that late data by updating the results. And there's two sort of ways to do that. So you can process data by, say, outputting those results every 10 seconds. And when you receive data that's late, that arrived after the computation for which it previously should have been belonged to arrives, you can incrementally compute the result. For example, if you're doing counts, you produce a 5. The late data comes in that's associated with that time window. You produce a 1, and you can add them later in post-processing. The key to this is the time that you're using. So when we're talking about using windows for real-time processing, there's two really important times. There's event time and processing time. Event time refers to the timestamp associated with the record. So it was basically the client's timestamp of the device. The processing time refers to the time of the application or the service that at the time of processing. So when you're dealing with IoT data, we typically recommend you use event time as your aggregation as a key, or arrival time. So there's various steps in the platform you can apply a timestamp there that might be a little bit more reliable than the actual event timestamp. But to use that as a key to get accurate information and possibly do checks to make sure that the event time coming in is accurate. But to trigger results by processing time. So if you only trigger dice by event time and you've got a large amount of devices that say, fell offline, you're not going to get a result continuously. So to use both timestamps in conjunction to get the results that you need that are both timely as well as can update later for late data that are accurate. So IoT customers are going to have missing data. They're going to have missing values, and there's a couple strategies to do with it. The one I'll highlight here is linear interpolation. So you might, over a 5-minute period, be receiving 3 or 4 events that were in the previous minutes. But what you really want is that what the value was at the 5th minute. A simple strategy is to use linear interpolation to process that data and project that value for it. Finally, performing upserts into the MySQL table. And you can insert any database of choice here. It could be MySQL, Postgres, it could be your data warehouse. The point of performing upserts, or insert on duplicate key update, is that is the last example about the late data arriving that I mentioned. So if you produce incremental value, so if you have a count of 5 and a late data comes in that is a count of 1 that was associated with an older timestamp, what you want to do is update the value in the database from 5 to 6. And this pattern allows you to do so. There are various other strategies, but it's just an important consideration. How you update your downstream data stores based off of late data is an important concept. So where do I go next? The next is sort of have a call to action. We would like you to try these use cases out yourself. And there's a lot of resources available to you to help do that. I highlight 2 examples. I follow the AWS Big Data and IoT blogs rather closely, and they have some great examples that you can walk through, complete the whole use case in anywhere from 10 minutes to an hour, and really get an idea of how to play with these services. Amazon Elasticsearch service, Amazon Kinesis Analytics provide a lot of value for doing real-time computations, but there's a lot of other options that are available to you on AWS platform. So use this as sort of a starting point to get ideas for where you go next. And then finally, what I'd like to bring up is the AWS IoT App Challenge. This is, again, what I highlighted at the beginning of the webinar. It's a challenge where you build an application that similar to the patterns I've highlighted in this presentation. That collects data using AWS IoT, processes that data in real time using Amazon Kinesis or a set of other services, and does something value for an end user. Thank you all for joining us today. I hope you learned something about what AWS services you can use to help do real-time analytics on AWS IoT platform and some ideas to implement your next use case. Thank you again. My name is Ryan Nienhuis, and try out the AWS IoT App Challenge.
Thanks so much, Ryan, for an awesome presentation, and to our moderators for answering all of the audience's questions. Again, we apologize if we were unable to get to all of your questions today. We do have a lot of questions coming through, and we'll do our best to answer them over the next couple of moments. If you have any feedback on today's webinar, as well as any suggestions on topics you'd like us to cover in future webinars, please drop us a line at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Thank you, and enjoy the rest of your day.